the last lecture, I introduced the logic of Aristotle in terms of a central visualization, the square of opposition. I want you to call that image to mind. Here's a quick review. In Venn diagrams, we use overlapping circles S and P for the two concepts involved. We black out areas to indicate there's nothing in that area. We use an X to indicate there is something there. All SRP is in the upper left of the square of opposition. We black out the area of S that isn't in the overlap with P. If all SRP, there aren't any that aren't P. No SRP is on the upper right. In this case, there's nothing in the overlap of S and P, so we black that out. In the lower left is some SRP. We use an X in the intersection to show that there's at least something in the overlap. Something is both S and P. Some S or not P is lower right, with an X in the outer S area to indicate there's at least one S outside the overlap with P. Some S's are not P. Then the magic. Contradictories are on the diagonals. They can't both be true, and they can't both be false. If one's true, the other has to be false. If one's false, the other has to be true. Implications run down the sides. If the upper one is true, the lower one is true. In that direction, truth is contagious. It flows from the top to the bottom. We call the correlate movement from the bottom up counterindication. If the lower one's false, the upper one has to be false too. Contraries face each other across the top. Both can be false, but both can't be true. Subcontraries face each other across the bottom. Both can be true, some are, some aren't, but both can't be false. This time I want to give you the rest of Aristotle's logic using another visualization. All of Aristotle's logic in 2 lectures. That's not bad, considering that Aristotle's logic remained the gold standard for over 2,000 years. Aristotle invented logic. At the core of that logic, and of all logic since, is one breathtaking idea. Maybe we can systematize thought. Concepts are the atoms of thought. In combination, they form the molecules we call propositions. It's the fundamental relations between propositions that shine out in the square of opposition. But it's the next step that's really the most important. Propositions don't just stand alone. Propositions go together to form arguments. In arguments, you see the dynamics of thought. Reasoning involves moving from one proposition to another and another beyond that. That's the movement of argument, from premises to a conclusion. There was a Monty Python skit called The Argument Clinic. I'm sure you can find it online. In that skit, Michael Palin plays the client. John Cleese is the guy behind the desk. Michael Palin enters the room. Is this the right room for an argument? I've told you once, says Cleese. No, you haven't. Yes, I have. It goes downhill from there. The whole joke turns on the term argument. What Cleese means by argument is the everyday sense of bickering conflict. At one point, the client says, an argument isn't just contradiction. An argument is a connected series of statements intended to establish a proposition. That's our sense of argument, the philosophical sense. A connected series of statements intended to establish a proposition. An argument in our sense represents the conceptual dynamic from proposition to conclusion. It's that movement of thought that is central to all rationality. But of course, it's not just intended transition that's important. We want to be able to evaluate arguments. When do a set of reasons really give you a solid inference? When does evidence really support a hypothesis? When do premises really entail a conclusion? What guarantees that a transition of thought is a rational transition? Those are questions about validity. When is the dynamics of thought rational? When is an argument valid? That's what Aristotle was after. That's what all logic is after. The whole purpose of logic is to capture validity, the crucial category of argument evaluation. Maybe we can systematize thought by capturing what makes it rational. Maybe we can formalize validity. Let me emphasize what that means. An argument is valid if the link between premises and conclusion is logically tight. I'll talk more about truth in a bit. The important first point, however, is that validity and truth are importantly different. The validity of an argument, the fact that there's a tight logical connection between premises and conclusion, doesn't guarantee that the premises are true. It doesn't guarantee that the conclusion's true. What you know when you know that an argument is valid is just this. If the premises are true, the conclusion must be true. That's important information, but it's conditional information. What you know is that the conclusion has to be true if the premises are true. In this lecture, I want to talk about ironclad, airtight validity. I'll leave lesser shades to a later lecture. We're starting with Aristotle, and Aristotle took as his target validity in the highest degree. Here's what it means for an argument to be valid in that strongest sense. If the premises are true, the conclusion absolutely must be true. If the premises are true, it's impossible for the conclusion to be false. You can't get a much tighter connection than that. If the premises are true, the conclusion is absolutely guaranteed. Let me give you 3 short arguments, each with 2 premises and a conclusion. You tell me which ones are valid. First argument. Rice is grown in every county of Louisiana. Any county that grows rice also harvests crawfish. Conclusion. Crawfish are harvested in every county of Louisiana. Valid or invalid? Second argument. All purple vegetables are poisonous. Carrots are a purple vegetable. Conclusion, carrots are poisonous. Valid or invalid? Third argument. The Declaration of Independence lays down a principle of self-determination, a right to life, liberty, and the pursuit of happiness. One man, one vote is a core principle in democratic decision-making. Conclusion, presumed innocent until proven guilty is a major principle of American law. Valid or invalid? Which of those are valid arguments? If you said the first 2 are valid and that the third one is not, you're absolutely right. But look at how that differs from truth. The propositions of the first argument may well be true, but when the question is validity, their truth doesn't really matter. If they're true, the conclusion has to be too. Validity is about the logical connection between premises and conclusion. All purple vegetables are poisonous. Carrots are a purple vegetable. Conclusion, carrots are poisonous. That's perfectly ridiculous, but it's also perfectly valid. Not all purple vegetables are poisonous, but suppose they were. Carrots aren't a purple vegetable, but suppose they were. If those 2 premises were both true, if carrots were purple vegetables and all purple vegetables were poisonous, it would also have to be true that carrots were poisonous. The first was a valid argument with true claims. The second was a valid argument with silly claims. In the third argument, we have all true claims again, but it's not valid. The Declaration of Independence lays down a principle of self-determination, a right to life, liberty, and the pursuit of happiness. One man, one vote is a core principle in democratic decision-making. Conclusion, presumed innocent until proven guilty is a major principle of American law. Those are all propositions about principles. They're all true. But that's not enough to make a valid argument. They lack the logical connection that validity demands. So let me see if you've got this. Suppose you've got an argument in which all premises and the conclusion are true. Is that a valid argument? Not necessarily. It's the connection that matters. You might have a valid argument in which all premises and the conclusion are true. That'd be great. But validity alone doesn't tell you that. You might have a valid argument in which all the premises and the conclusion are false. The purple carrots was one of those. You might, in fact, have a valid argument in which the premises are false, but the conclusion is true. Here's one. Everything poisonous is orange. Carrots are poisonous. Therefore, carrots are orange. That's a valid argument. If the premises are true, the conclusion has to be true. The premises are false, but they entail a conclusion that's true anyway. I guess sometimes two wrongs do make a right. There's only one pattern of truth and falsity that validity rules out. You will never find a valid argument that goes from true premises to a false conclusion. A valid argument is one in which, if the premises are true, the conclusion must be true. Aristotle's goal, the goal of all logic, is to capture what it is about an argument that makes it valid. The core insight, validity doesn't turn on what an argument is about. Validity is a matter of structure. Here, for example, are two arguments about very different things. Argument one, another silly one. All carrots are legumes. All legumes are delicious. Conclusion, all carrots are delicious. Argument two, not so silly. All countries in the Middle East are in turmoil. All states in turmoil have unpredictable futures. Conclusion, all countries in the Middle East have unpredictable futures. If one of those is valid, the other one is valid. Why? Because validity depends purely on the structure of the argument. Both of those have this structure. All A's are B's, all B's are C's, conclusion, all A's are C's. Validity depends not on content, but on structure. I don't think I would have ever seen that. Reasoning is so thoroughly human, as context-bound as the things it's about, as variable as the humans who do it. I don't think I would ever have seen that what makes it real reasoning, that what makes something a valid argument, is a matter of abstract structure. For that, we needed an Aristotle. Aristotle worked out the structure of ironclad validity in terms of three-step arguments called syllogisms. A syllogism takes us from categories to propositions to steps in an argument. It uses three categories overall, A, B, and C. It links those categories in pairs to make categorical propositions. All A's are B's, some B's are not C's. The syllogism itself is an argument in three propositional steps, with maybe a structure like this. All A's are B's, some B's are not C's, no C's are A's. Some syllogisms are valid, some are not. The one I just gave you is a syllogism, sure enough, but it's not a valid syllogism. So, is there some way of sorting the sheep from the goats? Is there some way of sorting the valid syllogisms from the invalid ones? There are lots of ways. The medieval monks memorized an exhaustive list using a code in terms of women's names to remember which syllogisms were valid and which weren't. Yep, those celibate medieval monks learned their logic by memorizing women's names. Barbara is virtuous and valid. Celise is not. But there is a much easier way. Here again, visualization is the key. We can do all of Aristotle's logic with the Venn diagrams you already have at your disposal. Remember the Venn diagrams for the categorical propositions. All S are P. No S are P. Some S are P. Some S are not P. Those are the propositional elements of syllogistic logic. But we said that syllogisms involve three propositions. Each proposition of the syllogism, each step in the argument, uses just two of our three categories. In order to use Venn diagrams to track validity, we need to overlap three circles into a triangular Venn diagram. Our first proposition, linking categories A and B, will look something like this. Our second, linking B and C, will look something like this. Our third, linking A and C, will look like this. All three categories and all three propositions come together in the syllogism. We put them together like this. The result is an overlap of three categories, just as the syllogism always involves three categories. The triangle is formed from three categorical propositions, pairs of linked circles. You should learn to see each of those pairs individually in that diagram. Let's take an easy syllogism. The medieval monks called it Barbara. All proteins are polypeptides. All polypeptides function by elaborate folding. Therefore, all proteins function by elaborate folding. That one's obviously valid. I'll use it to introduce the technique, which can then be used for cases that aren't so obvious. We've got three categories: proteins, polypeptides, and function by elaborate folding. We label the three circles in the diagram accordingly. We now enter each of our premises in Venn diagram style. So enter our first premise: all proteins are polypeptides. In order to do this, we act as if that bottom circle isn't even there. Fill in the shaded area just like we did before for all SRP. That'll mean shading in that whole left portion of proteins. All proteins are polypeptides. Now take the second proposition. All polypeptides function by elaborate folding. That premise is just about polypeptides and folding. We therefore concentrate on that part of the diagram, ignoring the protein circle. How do you represent all polypeptides function by elaborate folding? By striking out any polypeptides that aren't in the overlap with function by elaborate folding. Now step back and look at the diagram as a whole. Philosophers talk of logical space, and what we've just done is to map the logical space of our first two propositions. If those are both true, the diagram shows what the categorical universe must look like. Here comes the last step, the crucial step in telling whether a syllogism is valid. Some people find it the trickiest. We want to look at our third proposition, the conclusion, and ask whether its information is already in the diagram we've constructed for our premises. If it is, the argument is valid. If it's not, the argument is invalid. If the concluding information is already provided by the premises, it has to be true when they are valid. If the premises don't give us that information, the conclusion doesn't follow from the premises. Invalid. In order to test for validity, we want to know whether the concluding information is already there in the logical space of the premises. So, look at the diagram. What would it mean to draw in the conclusion, all proteins function by elaborate folding? That would mean looking at just protein and elaborate folding, those two circles on the left. For it to be true that all proteins function by elaborate folding, the protein area outside of the overlap would be blacked out. Take a look. That area is already blacked out. There aren't any proteins in our diagram that aren't already squeezed into some part of the function by elaborate folding area. That means that the information in step 3, the information in the conclusion, was already there in the premises. The sign of validity. If the premises are true, the conclusion has to be true. The information in the premises is sufficient to give us the information in the conclusion. The argument is valid. Think about that a minute, and let me emphasize 2 points. The first point is that what I've just told you actually does make sense. Let me convince you of that. I'll then deal with some lingering disappointment. Here's the make sense part. If we graph the information in the premises, and the information offered by the conclusion is already there, the argument is valid. Remember, we're talking about the highest degree of validity. If the premises are true, the conclusion has to be true. That's what's happening here. If the premises are true, the conclusion has to be true. precisely because the information in the conclusion is already there in the premises. If that weren't the case, if somehow the conclusion was telling you something new, then the information in the conclusion wouldn't already be in the premises. It would be independent of the premises, a rogue conclusion from somewhere else, not from the premises, and thus the argument wouldn't be valid. So it does make sense. A valid argument in the deductive sense is one that squeezes out in the conclusion some information that you already had. Kant speaks of an analytic proposition as one in which the predicate is already contained in the subject term. A valid deductive argument is one in which the information in the conclusion is already contained in the premises. It therefore makes sense that you can show an argument to be valid or invalid depending on whether the information in the conclusion is information already there in the premises. But that's a little disappointing. It means that a syllogism will never give you any really new information. I have a memory along those lines that I can date to when I was 5. Somehow I'd gotten the idea of a syllogism, or at least of stepped reasoning, though I'm not sure where. I would try to deduce conclusions as I imagined Sherlock Holmes would. Walking up the street to Wendy's house, I remember thinking something like this. If Wendy's brother is home, Brian is home. If Brian is home, Wendy won't be the only one home. So, if Wendy's brother is home, Wendy won't be the only one home. But that's obvious. I knew that already. I wanted ironclad, airtight, valid reasoning that would give me some genuinely new information. But whenever it was airtight, that kind of reasoning never seemed to give me anything new. I found that very disappointing when I was 5. Maybe I'm still a little disappointed. You can do all of Aristotle's logic, all the logic of the medievals, all the logic that we had for 2,000 years with those 3 circles. It gets a little trickier with the X's in some are or some are not, but not a whole lot. Consider, for example, anything alkaline turns red litmus paper blue. Some poisons are alkaline, therefore all poisons turn red litmus paper blue. Valid or invalid? Use the 3 circles again, this time marked alkaline, poison, and turns litmus paper blue. Now, using your ability to concentrate on just 2 circles at a time, put in the information of the first premise. Anything alkaline turns red litmus paper blue. That means nothing alkaline is outside of the turns red litmus paper blue area. We black out that upper left portion. Now what about the second premise? Some poisons are alkaline. That means that there is something, we'll say at least one thing, that's in the intersection of the left 2 circles. When we go to put it there, of course, we see that part of that area is blacked out already. Nothing there, so our X can't go there. It'll have to wedge into that middle area. There, right in front of us, we have all the information contained in our premises. Step 3, we test the syllogism by seeing whether the conclusion would tell us anything new. What does the conclusion say, and how would we graph that? All poisons turn litmus paper blue. That would mean that there are no poisons outside of the turns litmus paper blue area. Is that information there already? Is that information we have already? No. If it were there, that lower area would be blacked out already, but it isn't. We have a rogue conclusion. In addition to logical space beyond our premises, it doesn't follow. That argument is invalid. There were actually 2 little tricks in that last example that are worth noting as we go by. One is this. I quickly went from some poisons are alkaline to at least one. That is, in fact, a standard move in logic, to read some as meaning at least one. It's so standard, in fact, that it's become the technical meaning for some in standardized tests. If you ever have to take the GREs, the LSATs, the MCATs, and there's a question about some, just reread it as at least one. That makes things easier. But even logicians have to admit that it doesn't fit very well with how we ordinarily talk. In normal usage, the word some at least implies a plurality. If I just got married, I have a wife. Count them, one. So I guess it's true that I have at least one wife. But it would certainly be peculiar to say, I just got married, so I have some wives. The other trick in that last example is a visualization trick. We drew in the universal premise first. Anything alkaline turns red litmus paper blue. That told us when our X arrived that it had to squeeze over into the remaining white area. What if we had done the sum proposition first? Where would we have put the X? We would know that it would go in the overlap of poison and alkaline, for example, but on which side of that other line that's in there? In that case, we'd put it on the line in the relevant area as a way of reminding us that it might be on either side. A further universal premise might tell us that we have to nudge it one way or the other. That's how it works. In order to really incorporate Aristotle's logic, one needs to practice with lots of cases. But the technique's guaranteed. Every time, if you do it right, you'll be able to distinguish a deductively valid categorical syllogism from an invalid one. Here's another one for you to try. All absentee ballots have been counted. Some counted ballots were illegible. Therefore, some absentee ballots were illegible. Stop the tape, take a minute, and work it out. Valid or invalid? Here's what your diagram of the premises should look like. The conclusion is some absentee ballots were illegible. Is that information already there? No. It would be there if we knew that X, that's somewhere in the overlap between counted and illegible, were in that central area that's also the overlap between absentee and counted ballots. But we don't know that. We only know it's somewhere in that larger overlap. It could be in either portion. That makes sense. The first premise tells us that all absentee ballots were counted. But we don't know that only absentee ballots were counted. The second premise tells us that some counted ballots are illegible. It doesn't tell us which ones. The possibility is therefore left open that the counted and illegible ballots are not the absentee ones. In that case, it wouldn't be true that some absentee ballots were illegible. In that case, the premises would be true, but the conclusion false. The truth of those premises doesn't guarantee the truth of the conclusion. The argument is invalid. What I want you to remember is that three-circle technique and the concept of airtight, ironclad validity that it represents. With that visualization, you can test validity for any three-step syllogism. With that visualization, you have all of Aristotle's logic at your fingertips. But let me return for a minute to that aspect of disappointment. The concept of airtight, ironclad validity sets a standard for inference in which all the information in a conclusion has to already be contained somehow in the premises. For 2,000 years, ironclad, airtight validity was held up as the gold standard for all knowledge. But that meant all information had to flow from above, from something you already knew. Mathematics is about the only discipline that works that way. It's no surprise that axiomatic geometry was the standard for all knowledge. Aristotle's legacy, therefore, had a downside, too. It was only with the rise of empirical science and figures like Galileo that an alternative became clear. Maybe an inference from observed cases to universal laws is what we need. Maybe it's legitimate. Maybe it's rational, even if it isn't ironclad guaranteed in Aristotle's sense. If you weaken the demands on validity, you get the possibility of rational information expansion for the first time. Reasoning together with observation that offers new information. Ironclad won't give you new information. Anything that gives you new information won't be ironclad. We have bought the benefits of science by weakening our demands on validity, by giving up full Aristotelian certainty. I think it was worth the price. We'll start talking about reasoning and validity in that wider sense a few lectures down the line. Next time, however, I want to take a break for something equally important, but a little more fun. Next time, I want to offer a workshop on creative thinking.